in general, if you have two random variables, call them u and v, and you construct a linear combination of them, in general, what's the variance of u plus v or u minus v for any two random variables, u and v? I want Todd to stand up and shriek this out.
Variance of u plus or minus variance of v.
How about the variance of u plus the variance of v? Well, I usually probably saw it many years ago. 2ab times the covariance of u and v, right? What's going on under here? What's going on under the radical? What computations are we doing? What's the variance of a times u plus b times v plus c times w? Oh, this is a squared, b squared. Then you got the a squared times the variance of u plus b squared times the variance of v plus c squared times the variance of w plus all the covariances, right? So what's going on here underneath the radical? Why did I ask you that question? Why did I ask these questions and then ask you what's going on underneath the radical? What's the connection? Yeah, what's going on underneath the radical and how is it connected to what I did at the far right there? What's going on underneath the radical there with A transpose X transpose X inverse A? If alpha transpose was just 1 by 2 and alpha was 2 by 1, then it would be setting up this linear combination of the variances and covariances. Remember, just for the sake of argument, suppose our garden variety regression model where y is equal to x1 beta 1 plus x2 beta 2 plus u. That's our garden variety regression model. And we want to test the hypothesis. We want to test the hypothesis that beta 1 plus beta 2 is equal to 3, for example, against the alternate hypothesis that beta 1 plus beta 2 is not 3. In this case, alpha is equal to 1, 1. R is equal to 3, right? My random variable is I'm going to call it gamma. My random variable is beta hat 1 plus beta hat 2 minus 3. And now, in the numerator, I'm going to have that, my gamma hat, my new random variable. And then I need to know the variance of gamma hat. So the variance of gamma hat is going to be the variance of beta hat 1 plus the variance of beta hat 2 plus 2 times the covariance between beta hat 1 and beta hat 2. Correct? So the variance of beta, where beta is now the vector beta hat 1, the 2 by 1 vector beta hat 1, beta hat 2, is equal to sigma squared times x prime x inverse, or sigma squared times the 2 by 2 matrix, which has x prime x super 1, 1, because that's the row 1, column 1 element out of x transpose x inverse. So that's just invented this new notation. It's not x1 transpose x1. It's the row 1, column 1 element out of x transpose x inverse. And here I get, so this is a number. I get x transpose x super 2, 1. That's the row 2, column 1 element out of that inverse. And I get x prime x 1, 2. Those two numbers are the same, by the way. And then down here I get x prime x 2, 2. Sigma squared times x prime x super 1, 1 is the variance of beta hat 1. Sigma squared times x prime x super 2, 2 is the variance of beta hat 2. Sigma squared times x prime x super 1, 2 is the covariance between beta hat 1 and beta hat 2, right? That's why that's called a covariance matrix. On the main diagonal, we get the own variances, and the off diagonal, we get all the covariances. So given that alpha looks like that, I have sigma squared times alpha, which was that, post multiplied by, when I multiply all of that out, that one and that one, pick out the variance of beta hat 1. That one and that one, pick out the variance of beta hat 2. That one and that one, pick out the covariance, and that one and that one, pick out that covariance. So I ended up including 2 covariance terms and each of the own variances when I get all done with the multiplication. So what's going on underneath the radical is to figure out the variance of this linear combination of random variables. What's going on underneath the radical is the computation of the variance of the random variable in the numerator of the t-statistic. Since beta hat is a random vector, we pre-multiplied it by alpha transpose, and we turned it into a single random variable. Alpha transpose beta hat is the linear combination of random variables. And the variance of the linear combination of random variables is the sum of the variances plus all the covariances. So alpha transpose x inverse alpha is picking out all the variances and all the covariances that we need to use, and then adding all those terms together.